Hello and welcome to another visual pattern challenge. Here's our pattern today. We've got all these lightning bolts. There's step 1, step 2, here's step 3. And your challenge is to predict the number of lightning bolts in step 4. If you can do that, can you predict the number in step 43? And can you write an equation that could be used to predict the number of lightning bolts in any step at all? So that's the challenge. If you'd like to accept that, pause the video and work it out. All right, so what have we got going on here? And the question I'd like to ask first, just by looking at this, do you have a hunch? Can you tell if this is going to be linear or quadratic or, well, maybe something else? I think it's either linear or quadratic. Do you see any clues here that give you an idea about which one it is? Well, when I look at this, the first thing I notice is that we've got these patterns of odd numbers. So there's 3, 5, 7, and I'm used to seeing that kind of a pattern because, if you have 1 and then you add 2 more, or sorry, the next odd number, 3 more, you'd get 4. And if you add the next odd number, 5 more, you'd get 9. And that is the pattern of if we sum these rows as we go down, you get 1, 4, 9. You'd get the squares. So the first thing I noticed is these patterns of odd numbers. So maybe this is quadratic. Although we start at 3 and not 1, and actually then we don't have the succeeding or the preceding rows, right? We have 3, 5, 7, and then we have 5, 7, 9, and then we have 7, 9, 11. So maybe this isn't quadratic because it doesn't have all the preceding rows. Well, at least from what I've noticed so far, I think we can get step 4, right? So 3, 5, 7, 5, 7, 9, 7, 9, 11. So this must be 9, 11, 13 for step 4. That'd be my guess. Let's see, that is 33. So 33 is my prediction for step 4. Let's go ahead and analyze these numbers, and we'll know for sure if this is linear or quadratic by analyzing the differences. So we'll look at the step number and then the number of bolts. So this is 15 in step 1. And in step 2, I think that's 21. Yep. And then in step 3, that's going to be 27. And in step 4, we're predicting 33. So let's go ahead and take the difference between each step. 21 minus 15, that's 6. 27 minus 21 is 6. And 33 minus 27 is 6. So look at that. We got a constant in our differences, and that means this is indeed a linear pattern. So I was thrown off the scent at first because of this arrangement of succeeding odd numbers, but really this is linear because it doesn't have all those preceding rows. So when we have a linear pattern, we can use the equation for a line to model it, and this m, this slope, is the rate of change, the difference between each step. So y equals 6x. So once we've got that much, that's sort of the stem of the equation. Let's figure out what else we need to do. If I put this in for step 1, y equals 6 times, and we put the step number in for x, 6 times 1 would be 6. We've got way more than 6 here. So let's see, that would be 6, and then we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. We've got 9 more. So I think I have to add 9. So on our equation, our b here will be 9. Let's see if that actually works for step 2. So y equals 6 times 2 plus 9. 6 times 2 would be 12, plus 9 would be 21. Yeah, that's how many we got for step 2. Let's try this with step 3. Y equals 6 times 3 plus 9, and that's 18 plus 9. That's 27. Yeah, so this appears to be working. So it looks like our equation is y equals 6x plus 9. Now to get the number of lightning bolts in step 43, we'll just plug in 43 for the step number for x. So y equals 6 times 43 plus 9. And let's see, 6 times 43, 6 times 40 is 240, 6 times 3 is 18, so 258 plus 9 would be 267 lightning bolts in step 43. Is that what you got? Well, how did that go? Did you get 33 for the next step? Were you confused at all that this might be quadratic like I was, or did you see it was linear right off the bat? I'd like to know. Thanks, everybody.